Welcome to Braille Institute. Now discussing the conditional expectation of y, given that there is a condition x is equal to x. So we'll go through the one example. We have a dice. So this is a dice. So a dice have the 6 faces, 5, 3, 4, 1. So we have a dice. Dice have 6 faces. So this dice have 1, 2, 3, 4, 5, 6. If you are throwing this dice, one face will get one face. So there is a probability. It's a probability. What is a probability? Is a 1 by 6. 1 by 6. Each face have the chance of 1 by 6. So like that. So if you are throwing the dice, you will get the 1 by 6 chance of getting number 1 in the top of the dice. Number 2 in the top of the dice. Same way, now we are defining the random variables. We are defining the x is equal to 1 when it is an even number. If you are throwing even number, so 2, 4, 6, you have to get a 2, 4, 6. Then x is equal to 1. If you are throwing, we will get, if you are getting 2, 4, 6, then x is equal to 1. X is equal to 0, otherwise x is equal to 0. Same way, one more random variable we defined, y is equal to 1 if it is a prime number. What is a prime number? 2, 3, 5. These are the prime number. If you are getting 2 or 3 or 5, then y also is equal to 1. Y is equal to 0 otherwise. Then what will be our table? Content in the table, it will be like that. X, y. X, y. So there is a 6 chances is there. 1, 2, 3, 4, 5, 6. So x is equal to 1 when it is an even number. Here it is all are 1 and otherwise 0. So we can write it is all 0. Y is equal to 1 when it is a prime number. So here it is a 1. Otherwise all are 0. So this is our table. Now we are going to find out what is the value of expected value of x given that y is equal to 1. So we have given the condition, the expected value of x given the condition that y is equal to 1. So we have y is equal to 1. So we have 3 cases. Y is equal to 1. In that, what is the value of expected value of the x? So equal to, we have 3 cases we have to consider. Here it is a 1 plus, here it is a 0 plus, this one here value is 0. So what is the value divided by 3? So 1 by 3 is the expected value of x given the condition y is equal to 1. Same way, expected value of x given the condition y is equal to 0. Y is equal to 0. What is the value? 0 plus, here it is 0, then x value is 1 plus it is 0, x value is 1. So they divide by 3. So this is a 2 by 3. So expected value of x given the condition y is equal to 1. So we have 3 cases, y is equal to 1. So we find out the expected value. Same way, expected value of y given the condition x is equal to 1. So x is equal to 1, here it is 1 plus x is equal to 1, y value is 0 plus x is equal to 1, y value is 0, all divided by, there is a chance of 3, 1 by 3. Same way we can write expectation of y, x is equal to 0. So this is also x is equal to 0, 0 plus, it is a 1 plus 0, here is y value is equal to 1, divided by 3. So this is a 2 by 3. So same way. So this is, if you have this table, we will get the values. Now we are finding out what is the formula for the conditional expectation. So we already studied the probability of we know how to write the probability of y given x in last chapter. If there is a 2 random variables, we know how to write the y given x. This one we can write like that. Probability of y and y, x is equal to s. So what is the formula for this one? Last chapter we have studied s is equal to x whole divided by probability of x is equal to x. So this is the formula for the probability of y given x. Probability of y given x, probability of y is equal to y, x is equal to x, probability x is equal to x. So now how to write the conditional probability of x given y? How to write the conditional probability? Conditional probability of expectation of, how to write expectation of y given x. So this one we can write, this one we can write, it is a same way. Here how to write the expectation of x? Expectation of x we will write like that. Expectation of x is equal to, expectation of x is equal to x into sigma, expectation of x we can write sigma x probability of x is equal to x. So same way we can write here sigma y, here is a condition of y, probability of y is equal to y given that x is equal to x. So this is a condition. So same way, it's a probability of x is equal to x. Same way we can write y is equal to y given that condition of x is equal to x. So this one, that is a formula. Here there is a formula, we can substitute this formula. So sigma y probability of y is equal to y, x is equal to x. The same formula we substituted here, x is equal to x. The same formula we substituted here. Just expectation of y bar, y given condition of x. So expectation of x we can write like that, x multiply with the probability of x. So this is a conditional probability y given x. So we written the formula. So we can check with the example how to get the, how to use this formula in discrete case. So we can check with one discrete case how to use this formula. So there is a y value is at 10, 20 and 30, and x value is equal to 1 and 2. So there is a chances x value is equal to 1 and 2, and probability is equal to 0.2. Here it is a 0.2, here it is 0.1. If x is equal to 1, then it is a 0.2, and this one is a 0.2, 0.3 and 0. If y is equal to 10 and x is equal to 1, it is a 0.2. Y is equal to 20, x is equal to 1 is 0.2, like that. So this is our table. How to use this formula? Expectation of, we need to find out the expectation of y given that x is equal to 1. Condition, expectation of y given the x is equal to 1. From the joint probability table, how to find out the expectation of y given the x is equal to 1. So we have a formula, expectation of y given the x is equal to 1. So applying the formula, y is, first case y is equal to 10. So we have taken the 10. First case is taken 10. Multiply with the probability of y is equal to 10. Then we have to write like that. Probability of y is equal to 10 and x is equal to 1. All divided by probability of x is equal to 1. So what will be the probability of x is equal to 1? Probability of x is equal to 1, it is a whole probability. So this is equal to 0.5. Probability of x is equal to 1 is equal to this whole probability 0.2 plus 0.2 plus 0.1 is 0.5. Probability of x is equal to 2, that also 0.5. 0.2 plus 0.5. Now we have to substitute. Here we are substituting 10 multiply with y is equal to 10 and x is equal to 1. X is equal to 1 and y is equal to 10. So this probability is 0.2. 0.2 divided by probability x is equal to 1. So that is a 0.5. 0.5 plus we need to find out all the y, all the cases, sum of y. So we need to find out all the cases. So next case is 20, y is equal to 20. In y is equal to 20, how to find out? Here it is a 20 and this is a 20. Then 20 multiplied with the y is equal to 20 and x is equal to 1. So this is also 0.2 divided by 0.5. Probability of x is equal to 1 is same. Plus next is y is equal to 30. 30 is so here it is a 30. Here it is 30. So y is equal to 30 and x is equal to 1. So this is a 0.1 divided by 0.5. So this is a total, will get 18. Total will get 18. So this is a method. Discrete cases will get the table, and this is a method to find out the expectation of y given the condition of s is equal to x. We can change x is equal to 1 or x is equal to 2, what are the values, then we will get the what is the expectation of y given x is equal to 1 or 2. Now it is a continuous distribution. If you move to the continuous distribution, we can write the same way. Expectation of continuous distribution y given x. So continuous distribution, how to write? Is the opposite. We have to write the integration. We have to return the integration in terms of y. How to write the in terms of y? Here it is a y and a probability. You have to write the probability. Here we will write the f of y given x and dy. So here it is a probability of y given x. Y given x. So same way in continuous distribution we will write like that. This f of y given x, f of small letter f y given x, this one we know that f of x comma y divided by f of s. We know this one, f of xy and f of x. So this one we can substitute like that. So if substituting, we will get expectation of y given x is equal to integration of y. Here it is a f of x comma y dy whole divided by f of x. This f of x we can write like that. F of x is same. That is the same. F of x or f of x like that same. So this is a formula for the expectation of y given x. So this is a continuous distribution. We can check with some example. You can do some example. F of x comma y is equal to 3 by 5 x plus 1 x plus 1 s plus y, not 1, x plus y. So this is a formula. F of xy is equal to 3 by 5 x plus y. We need to find out the expectation of y given s is equal to x, given the condition s is equal to x. So this is the formula. F of xy, joint probability distribution formula is a 3 by 5 x into s plus y. In this case, it's a continuous distribution. First we need to find out f of x. So there is a condition here is given 0 to x is equal to 1 and y is equal to 0 to less than y is less than 2. There is an interval. Continuous distribution, we need to know the what is the interval. X is equal to 0 to 1 and y is 0 to 2. So here f of x, first we need to find out the f of x. So this is a formula. So first we need to find out the f of x. F of x we are already studied in the last chapter how to find out the f of x. F of x means we need to integrate the in terms of y 0 to 2. Y we need to remove. So in terms of y, 3 by 5 x plus y in terms of y. So we are now integrating the in terms of y. So how to get this value? 3 by 5 x plus y dy. So this is equal to, this we can write integration of 0 to 2. This we can multiply here. So we will get s square and s plus sy. So we will get like that. You see, s square plus sy. Now if we are integrating, we will get 3 by 5. 3 by 5 is taken out. And h square in terms of y. So h square y plus h y square divided by 2 in terms of y, 0 to 2. Just we are integrated h square y and h y square divided by 2. Now you see, 2 if we are giving here, it is 3 by 5. 2 is giving instead of y. So 2h square plus h 4 divided by 2. So this one is become 2. So it is become 2h. 2h. So f of sh we got the like that. So this one we can write 6 by 5 h square plus h. Or we can write this is, we can write 6 by 5 h s plus 1. You can write like that also. So we got that f of sh is equal to 6 divided by 5 h s plus 1. Now you are substituting this value in here. So what will be our expectation of y? Just integration. This is a formula which is substituting here. So this is equal to integration of y. F of sy we know that 3 by 5 s plus y whole divided by f of x, that is a 6 by 5 s plus 1. This is a dy again in the terms of dy. So what will be the 3 by 5? 5 we can cancel it. Here is a 5. 5 we can cancel with the here. So it is become like that. And the x also is there. X also we can cut. So x also I just removed. And 3 by 6. 3 we can remove. Here it is become 2. That is become 2. So y multiply with s plus y divided by 2s plus 1 dy. So we need to integrate with 0 to 2. So y is multiplying here. So it is become yx plus y square. So we got the yx plus y square. 2s plus 1 is a constant, we can take out. So what will be the value? 1 divided by 2s plus 1 is taken out. Here it is a y plus x plus y square in terms of y. We are going to integrate in terms of y. So x, here it is y square divided by 2 plus y cube divided by 3. Yes, 0 to 2. So x, y in terms of y, we are integrating in terms of y square divided by 2, y cube divided by 3. So what will be the answer? 0 to 2, if you are giving 2, it is become 4. It become 4. Giving 2, it is become 2 raised to cube, 8. 8 divided by 3. This become 2x plus 8 divided by 3. This we can take out. So it is become 4 by 3. And this 2 we can remove. So it is become like that. So we got the s plus 4 divided by 3 whole divided by s plus 1. This 3 taken here, 3x whole divided by 3s plus 1. So we got the formula expectation of y given x. We got the formula 3x plus 4 divided by 3 of s plus 1. So this is the answer, 3s plus 4 divided by 3 of s plus 1. So expectation of y given the condition of x. So we got the value of expected values in terms of function of x. We got the in terms of function of x. So this expectation of y given x, expectation of y given x is given the function of x. This one we are to important. Y given x is equal to 3x plus 4. So this is in the term in function of x. Here is a s value we can change terms of x. So this is the expectation of y given as in a continuous distribution. We got the formula of y, f of xy, f of x. Same way, we have a discrete cases, sigma y, probability of y is equal to y, x is equal to x, and probability of x is equal to x. So we considered both the cases, discrete and continuous case. Hope you understood the conditional expectation. Thank you.